5 very specifically wants me to solve using completing the square. And the steps for completing the square were first to isolate the constant, and that's done for me on this problem. The number without the letters, the constant, it's by itself on the right-hand side. The second step to solve by completing the square is to add c to both sides. Then I'm going to change c to a number. C is always found by taking the number in front of the first power term, dividing it by 2, and then squaring it. The computation for finding the C helps me factor the left-hand side. So I change C to a number. I'm going to lazy factor the left-hand side and combine on the right-hand side. That number in the parentheses with an exponent of 2 is what's going to wind up being in my parentheses that has a square. And then I solve by square rooting plus or minus square rooting. So square root plus or minus square root. The left-hand side, when I square root it, I just get p plus 2. The right-hand side, 6 isn't a reducible square root because its prime factoring is 2 times 3 and there's no pairs in it. Finishes up by solving for p by minusing 2 from both sides. Because there's a square root left, my best answer has a plus or minus sign. I can't combine negative 2 plus the square root of 6. Those aren't addable, so my best answer is going to be this right here. That's not necessary to check. The very next problem is the one that I need to check. The only problem on the test where I need to check. 6a wants me to solve a problem with a square root. And when we did this kind of problem, the first step of the algebra was to isolate the radical without introducing a fraction. That's done here and it's done on the test. 2 is to square both sides. So on the left side, I'm going to go p minus 8 quantity squared. On the right hand side, I'm going to do 2 square root of p quantity squared. On the left-hand side, the minus between the p and the 8 makes me write it with 2 parentheses and to do the 4 multiplications. The right-hand side straight multiplication, so I'm allowed to just square the 2 and square the square root of p. The left-hand side, I get p times p times minus 8 times p, and minus 8 times minus 8. The left-hand side is going to be p squared minus 8p minus 8p plus 64, which is p squared minus 16p plus 64. The right-hand side, when I square the 2, I get 4, and when I square the square root of p, I get p. After I get everything all cleaned up on the second step, I want to set it equal to 0. And depending if I'm comfortable factoring, factor. If I'm not comfortable factoring, quadratic formula. I could factor this, but that's a little bit too much to factor. So I'm going to solve this by the quadratic formula. I'm going to go a equal to 1, b equal to minus 20, c equal to 64, and go p equals to negative, b is negative, so it goes in a parentheses, negative, negative 20, but it's negative b, plus or minus the square root of b squared. Since b is negative, it goes into parentheses, minus 4 times a times c, which is 4 times 1 times 64, over 2a, which is 2 times 1. Under the radical, I go negative 20 squared minus 4 times 1 times 64. Under the radical, I get 144. So this is going to give me p equals to positive 20. That double negative goes positive, plus or minus the square root of 144 over 2. The square root of 144 is 12. So this is 20 plus or minus 12 over 2. Since I don't have an I and I don't have a square root, I shouldn't have a plus or minus in my answer. I should separate and do 20 plus 12 over 2 and 20 minus 12 over 2. The 20 plus 12 is 32 over 2, which is 16. The 20 minus 12 is 8 over 2, which is 4. This is the only problem on the test that you could do perfect algebra and write an answer that doesn't check. If a problem starts with a square root and I square to get rid of a square root, it's 100% necessary to check. So the initial problem for my checking is p minus 8 equals 2 times the square root of p. I'm going to see if 16 minus 8 equals 2 times the square root of 16. And then I'll see if 4 minus 8 equals 2 times the square root of 4. I can do this in my head. This left one is just 8. 16 minus 8 is 8. And 2 square root of 16 is 8. 16 checks. On the other side, 4 minus 8 is negative 4. And 2 times the square root of 4 is positive 4. The 4 doesn't check. It doesn't really belong in my answer. If I put it in my answer, I need to say that it doesn't check or it's extraneous. And the 16 checks. So when I go to write my answer, it's best just to write the one that checks. So when I go to write my answer, I could just say p equal to 16. That's kind of the best answer. Or I could say p equal to 16, p equal to 4 doesn't check. And the fancy word for doesn't check is extraneous. Both of these would be okay. Part B of number 6, I don't have to check, but I have to do fancy factoring. I can't use the quadratic formula. The quadratic formula doesn't work for fourth powers. So I need to factor this. And when I go to factor this, the exponent in the middle is the exponent that leads my x's. In this case, it's going to be x squared. My numbers need to be plus and minus. They need to multiply to negative 18. They need to subtract to negative 7. And that's going to be 2 and negative 9, because 2 times negative 9 is negative 18. And 2 minus 9 is negative 7. So I'm going to get a plus 2 and a minus 9. So these fourth power ones, the first step is to factor. After we factor, we set each parentheses equal to 0. Get the numbers and letters on the opposite side and solve by square rooting plus or minus square rooting. So I factored. Generic factoring other than the x is an x squared. And now I'm going to get the x squared on opposite side from the constant for each one of these and square root plus or minus square root. The square root of negative 2, if I'm in mode 2, is just rad 2 times I. And the square root of 9 is just 3. So for part B, these will all check. They're really a nuisance to check because you can't do fourth powers with i's on my calculator. It's going to be plus or minus the square root of 2 times I. The I is after the radical. And plus or minus 3. I don't know if I could squeeze C in here, but C we did with U's. Boy, if you looked at my handout for this, I might have not done it with U's. There's two ways to do these problems, and I vary from semester to semester how I do them. Let me do part C on an bigger sheet of paper, so I'm not crunching it in there, because when I try to crunch, I make more mistakes. So in the video, I did these with U's. There's another way to do them. Maybe I'll record a second version of this showing how to do it without U's. But for these double parentheses, common parentheses problem, we change the inside of the parentheses to U's. Then we solve the problem with U's. In this case, I'm going to solve by factoring, but I could use the quadratic formula if I can't factor that. For factoring, the numbers need to multiply to negative 14, which means 1's plus and 1 minus. They need to subtract a 2. And 7 and minus 2 do that just fine, because 7 times 2 is minus 14. 7 minus 2 is 5. Once I get the U version of the problem factored, I split the factors up, take each factor and isolate the U, and then we take the U and plug it back into the equation U equal x plus 3 and solve for x. So I'm going to get negative 7 equals x plus 3, and I'm going to get 2 equals x plus 3 by changing each of the U's into that equation, or putting U's into that equation. And then I'm just going to isolate the x by minusing the 3. These don't really need to check, but if you make a math error, checking will save you losing points. Hopefully I didn't make a math error. I haven't been checking any of my answers, so I have just gobs of videos to do in such a short time to do them. We're on the coronavirus break right now, and campus is getting ready to shut down. The last two problems are the stuff from 5-6, where I need to break the graph, if it's given, into the region to the left of the x-axis, between left of the x-intercepts, between the x-intercepts, and to the right of the x-intercepts. And figure out which is our greater and which are less thans. So 7 on our review has an x-intercept at negative 2, has an x-intercept at 6. It's an upside down parabola. Looks something, not a lot like that, but something like that. So I need to make the region to the left of the x-intercept, between the x-intercepts, and to the right of the x-intercept. And I'm going to exclude the x-intercept, and I'm going to include the x-intercept. The first region goes from the far left edge of the x-axis, which has an x-coordinate of negative infinity, up to the x-coordinate of the x-intercept, which is negative 2. If I'm not including the x-intercept, I round bracket it. If I am including the x-intercept, I square bracket. Then I do the region between the x-intercepts. That goes from the x-intercept at negative 2 to the x-intercept at 6. Round brackets if I'm excluding the x-intercepts. Square brackets if I'm including the x-intercepts. And then the region to the right of the x-intercept. Round bracket if I'm excluding the x-intercept on the x-intercept. Square bracket on the x-intercept if I'm including it. Now I start figuring out what these regions represent. The outside regions, the graph is beneath the x-axis, so the outside regions are for less thans, because that corresponds to beneath the x-axis. So less than without a square bracket, you don't get the or equal to. When you include the x-intercept, you get the or equal to. So the outside intervals are going to be my less thans, And my middle interval, because the graph is above the x-axis, my middle interval is going to be a greater than. So this is going to go less than, greater than, less than. They always alternate for us. And the middle one, without the x-intercepts, just a greater than but not equal to 0. Including the x-intercept, you tack on the 0 part. Now I can answer all my questions. Part A wants me to find where the x's where it equals to 0. That's just asking for the x-intercepts without the 0 part. So that's just -2 and 6. Part B wants the greater than 0, which is at -2 to 6. Part C wants the less than zeros, which is the -infinity to -2 and 6 to infinity. And then D and E want the squared up ones. D wants the including the x-intercept and greater than 0. And E wants me these out ones, less y's that are negative or equal to 0. Always our B and D match up except they're squared up, and our C and E match up but they're squared up. Right, one last problem, and here I need to make my graph. I need to find the x-intercepts and plot the vertex. So in problem 8, I'm first going to find the x-intercepts by taking the function that's given. I'm going to set it equal to 0, and I'm going to factor. I can factor that in my head, and I only have 5 minutes left, so I'm going to factor it quickly. After I get it factored, I split the factors up, separately set each one equal to 0, and those are going to give me the x-intercepts to plot on the x-axis. I'm just going to plot the numbers on the x-axis. I need a mini table. I just need to get the one vertex part of my table, and I need to use the -b over 2a formula to get that table started because of the multiple x's without the parentheses. A is going to be 1, b is going to be 6, -b is going to be -6, 2a is 2 times 1. That's going to be -6 over 2, which is -3. I need to get the y-coordinate of the vertex by going -3 squared plus 6 times -3 minus 16. So -3 squared plus 6 times -3 minus 16. Y-coordinate of my vertex is -25. Good enough. Now I'm going to sketch a graph. I'm going to put -8 on the x-axis, +2 on the x-axis, and the vertex, -3, -25, maybe down there somewhere, so it doesn't have to be that accurate, and just connect. Go through the x-intercept to the vertex, x-intercept to the vertex. Now I'm going to make my regions. My region to the left of the x-intercept, between the x-intercepts, I don't need that 3 on there, and to the right of the x-intercepts. I'm going to exclude the x-intercept and include the x-intercept. First region, excluding the x-intercept, double round parentheses, -infinity to -8. If I include the x-intercept, I square up the bracket on the -8. Between the x-intercepts, -8 to 2, double round parentheses, I'm excluding the x-intercept for the less thans or greater thans without the or equal to's, including for the less thans or equal to's and greater thans or equal to's, square them up. And to the right of the x-intercept, 2 to infinity, double round bracket if I want the less thans and greater thans without the or equal to's, square bracket if I want the greater than or equal to or less than or equal to. Now I'm going to analyze these. This is above the x-axis, this is above the x-axis, that's a greater than, that's a greater than. And in the middle, the graph is beneath the x-axis, it's a less than. This one up here, it went greater than, less than, because the middle was above the x-axis. Here the middle's beneath the x-axis, it's less than. There the middle's above the x-axis, it's greater than. These always flip-flop. So this one is going to be a greater than without the or equal to. This one's going to be a greater than with the or equal to. This one's going to be a less than without the or equal to. This one's going to be a less than with the or equal to. Far right one, a greater than without the or equal to, and then a greater than with the or equal to. Now I can answer the questions right directly. Part A just wants the x coordinates of the x-intercepts, which are x equal to -8 and +2. Part B wants these rounded up ones that are greater than zeros. So the -infinity to -8 union 2 to infinity. Part C wants the rounded up one where the less than 0, so -8 to 2. And then D just wants me to square up the brackets for B, taking those bottom ones. -infinity to -8 square bracket as opposed to round bracket. 2 to infinity square bracket as opposed to round bracket. And the last one, E, just wants me to square up the brackets for C and get -8 to 2. That's a lot. This is a meaty chapter. There's a lot of variation in this chapter. It's a good prep for college algebra because that happens so often in college algebra that the chapters get really diverse. So I'm going to pause the video. Hopefully we're feeling good enough to do the test on this.